Hi, today we shall be developing panel data using following methods. They are pooled OLS model, fixed effect model, and random effect model. And here we have taken four countries such as 1, 2, 3, and 4. And also we have three variables such as GDP, import, and export. And here GDP is the dependent variable and import and export are the independent variables. Okay, our first model is pooled OLS regression model. Here we pool all observation together and run the regression model, neglecting the cross-section and time series nature of data. By combining four countries by pooling data, we deny the heterogeneity or individuality that may exist among four countries. In other words, we assume that four countries are same. We assume that four countries are same, and that is why I have run this pooled OLS regression model. And our second model is fixed effect model. The fixed effect model allows for heterogeneity or individuality among four countries by allowing to have its own intercept value. In this model, we assume that four countries, not companies, four countries may not be same, right? So here four countries may not be same under fixed effect model. And finally random effect model. Here four countries have a common mean value for the intercept. Okay, finally I talk about the terms of uses of this website. Okay, but first I show you my data that we have about the data for the four countries, and we have three variables: GDP, export, import, and the country and the year. So this is the data for four countries, right? Total data, you can see data for four countries, and there are four countries. So this is country 1, 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 and the data is for each country from the year 2000 until 2010. That is our year 2000 to 2010, and this is year country 2. Country 2 begins from the year 2000 until 2010. That is country 2. Again, country 3 begins with 2000 until 2010. Country 4, as before, begin from 2000 and until 2010. So this is my data to run this model, and here I shall use our software, right, to run panel model. And our software is a free software. You can download it from online. Okay, so now I can start my model. So this is R, right? R software. So here I have to write the program. So I write it. Install the packages that you have to do from online. Uh, so so you have to write the program in this way. So I am writing the program install packages PLM. Okay, then I have to enter. Okay, okay, then I have to find out the place where you stay. So then press OK. Okay, then the whole thing is being downloaded. Okay, okay, then you have to write the command library plm. Write this command, then enter. Okay, okay, then you have to write the command my data read CSV. Our file is CSV in nature. So and the file is is uh, is under C drive and under folder number economics 2, and the file name is GDP, and it is CSV file, and give it this one and this one. So this is the command you have to write exactly, right? So then we have done it, then enter again. Make sure your command must be very much accurate, otherwise the result will not come. So I press enter, then you have to write attach, then my data, right? You can see here is my data, so you have to write my data here. So I enter. Okay, now I have to set dependent variable and independent variable. So suppose why I write it this way, cbind and GDP is the dependent variable and y can represent GDP. So y cbind GDP, enter. Okay, then x can represent the independent variable, and we have two independent variable, one is export and one is import. So you write it. So we are set, then we press enter, it is set. Okay, and now first I estimate the pooled OLS model, that I estimate first. So the command would be, just 1 minute, the command would be something like this. Just give me 1 minute. The command for pooled OLS model should be just 1 minute. Okay, so the command would be for pooling model. I just type it, just 1 minute. Pooling by this and this PLM, then y by, sorry, y by x, then data and my data, then comma, index equals C, and we have the country is the one data, then the year, we have the year also, then bracket closed, then model equal to pooling model, and the bracket closed, sorry, bracket closed. Okay, make sure my command is alright, otherwise, okay, I make it big slightly so that you can see better, right? Okay, pooling PLM, YX data, my data index C, country, year, model, pooling. I think my setting is alright. So then I press enter. Yes, it is alright. Then I write summary and the pooling, right? So that is my program command, and you enter. You can see from here, so summary of pooling, and it is a balance panel, right? And here you can see, so this is the arms, and you can see export and import are the independent variable, and GDP is the dependent variable. And here you can see that is export divided by standard error. I can get t value and the corresponding probability value, right? And so here I can see export is a significant variable because probability value is very small, right? And import is also significant variable to explain GDP because the probability is very small, less than 5%, right? So that means both the independent variable are significant, and F statistics is also significant because it is very small. So all the things are very good. So we are happy about this pooling OLS model. Okay, now I can estimate our second model, fixed effect model, that we have. So we have to write similar command like pooling model. Okay, I write fixed, then similar model, similar PLM, then I write y by x, comma, data equal my data, comma, then index equals C, then country, okay, then comma, then year, comma, then bracket closed, okay, then model is within, right? That is our model, and bracket closed. Okay, that is our fixed effect model. So here in this model, so I think, well, I have write it properly. I just double check fixed PLM data, my index C, country, I think this is fine. Then I press enter. Then as before, write the summary should be fixed, right? So that is my model, enter. Okay, you can see, so that is the C, and this is the outcomes, right? Efficient. And in this model we assume that all the 4 countries are not same, right? They may not be same, they are different. Okay, and here export is not a significant variable because probability value is very high, 96.59%, but the import is a significant variable because probability is 2.316%. So import is a significant variable, but at F statistics actually this is significant at 10% level but not at 5% level. Okay, so this is my fixed effect model. And what about the last model we have? That is our random effect model. So we estimate it as before. I write the random, right, and PLM y by x comma data my data, then index equals C, then country, then year, then bracket close, then model equal random, then bracket close. So yes, so data C is okay, random. I just double check. Okay, it's fine. And I have done some mistake somewhere. Yes, that is why result is not coming. Okay, I write again. I've done some mistake. PLM. So always be careful. Data my data, then index equals C by country, this one, comma year. There should be 2. You see from here, last time it should be 2, but here I put only 1. That is why the result did not come. Okay, other things remain unchanged. Random. Okay, but we have to check again. Y exact data, my data index, C, country, year, model, random. I think this time is very fine, no problem. I press enter. Yeah, it is working. Then summary, then random, right? So this is my random effect model. I press enter. So you can see random effect model. The result has come up. Sorry, the result has come up of random effect model, right? So, and here is the coefficient, and you can see export is not a significant variable because p value is 98.235%, and import is not a significant variable also to explain GDP because probability is 28.62%, and F statistics is significant at all because p value is very high. So this model that means this F statistics is not significant, so probably that is not a good sign for the model. Okay, now I check. So we have estimated 3 models, pooled OLS models, and where we assume that all the countries are same. Then we have estimated fixed effect model. There we assume that probably all 4 countries are not same. And finally I have estimated random effect model. And now out of 3 models, which model we should follow to explain our data? Okay, so we do one by one, right? Okay, so first I check between I make it small slightly. I don't need that big area. Okay, make it something like this. Okay, something like this. Okay, sounds good. Okay, sounds good. Okay, sounds good. Okay, now between, first I check between fixed effect and random effect. Okay, so now here I shall appoint Hausman test to check which model is good, which model we should take between fixed effect and random effect model. And here I have taken Hausman test. And what is our null hypothesis for this one? Just 1 minute. I just set my null hypothesis first to check the Hausman test. So why is it just 1 minute? I'm checking. So our null should be okay. Our null is our null hypothesis is random effect model is appropriate, that is null, and alternative hypothesis is fixed effect model is appropriate, right? Okay, now I shall apply the Hausman test to check it. The command is, I write the command here, pH test first bracket fixed and random, right? I think command is alright. Still I double check. Yes, it's alright. I press enter. The result has come up. Hausman test, chi-square value and corresponding probability value. Here probability value is 8.901%, which is more than 5%. So I cannot reject null hypothesis, rather we accept null hypothesis. But suppose I assume that I take 10% level of significance. In that case I can reject the null hypothesis because probability is 8.901%, which is less than 10%. So meaning that if I reject the null hypothesis, then I accept the alternative hypothesis, meaning that fixed effect model is a appropriate model. Okay, so now we have seen that fixed effect model is appropriate model between these two models. Okay, now I need to check that between fixed effect model and pooled OLS model, which one is appropriate, that we can decide. So we can do the test between these two, and we have a command to do it. Just 1 minute. And here our null hypothesis is that just 1 minute, I write the null hypothesis. Null is pooling OLS model is appropriate. Alternative hypothesis is fixed effect model is appropriate. Okay, so here I said the command. Now write the command should be pf test, right, by between fixed and pooling. pf test fixed and pooling, then I enter. Okay, so it is called F test for individual affect, right? And here you can see the F statistics, right? And corresponding probability value. Probability value is very small, less than 5%, meaning that I can reject the null hypothesis and can accept the alternative hypothesis, meaning that fixed effect model is the most appropriate model, because because I have rejected the null and accepted the alternative hypothesis. So fixed effect model is the best model. Out of three models, here we have seen that we can see that fixed effect model is the best model. Okay, now we can check whether this fixed effect model has a serial correlation or not, right? That we can check. I said the null hypothesis again. There is no serial correlation, right? That I write it. An alternative, there is serial correlation, right? That we have said now. Okay, so I write the command. Alright, I write the command to check it. The command should be pcd test by first bracket fixed by test equals c by cd and two double bracket. You need two double bracket. Make sure if you don't put two, the result will not be right. Okay, pcd test fixed test. I'm just double checking cd c. Okay, then I can press enter. Result has come up. It is the outcome of the Pesaran CD test, right? And here you can see the Z value, corresponding probability, which is 92.03%, meaning that more than 5% I cannot reject null hypothesis, rather I accept null hypothesis, meaning that there is no serial correlation, and that is a good sign and that is desirable. So thank you very much for being with me. And here I can just see our fixed effect model for a while, that we have accepted it. That is, here you can see. So here, so this is the fixed effect model result, right? Fixed effect model outcome. So this model is the most appropriate model, and here export is not a significant variable, but import is a significant variable, because the probability is very small, 2.3%. So import can influence GDP, right? And the coefficient sign is positive, meaning that there is a positive associationship between import and GDP. And finally, F statistics is not significant at 5% level, but it is significant at 10% level. So we can still accept the model. Thank you very much for being with me for a while.